Welcome to this lecture session on distillation. The purpose of this particular session is to bring the concepts of what is a distillation tower, what are the various equipment involved, various equipment involved in its operation, the system considered, or the system which I am going to explain is a binary system. So this is a simple preface of this video, and this binary system I am saying it is considering components a plus b, and in this a is or shall I shall write it here. Yeah, so the binary system which is being considered is a mixture of a plus b. So this is liquid mixture, and I am saying, or let us assume, a is more volatile component and b is less volatile component. So we should actually know what does this more volatile or less volatile means. So if I refer the boiling points of the two components, if the boiling point of B is 100 degrees centigrade, so definitely the boiling point of A is much less than 100 degrees centigrade. To carry out a distillation tower or a fractional distillation tower operation, this difference in the boiling point should be greater than 25 degrees centigrade. Then I say we can actually greater than or equal to, we can say greater than or equal to 25 degrees centigrade. Then we can say that a fractional distillation operation can be employed. Okay, right. Now, so let's go to the next step here. I think hope you have understood the assumptions. Actually, I am considering a what you call binary system consisting of two components A and B, in which A is the more volatile component and B is the what you call less volatile component among the what you call the components present. Yeah. Now, operation. How do I operate a distillation column? So we finished a what you call preface. Now I'm trying to actually discuss on how do I operate a distillation tower. A distillation tower. Okay. So let us see the distillation tower here. So simple distillation tower. So this is a shell of the distillation tower. Yeah. So I'm considering is not to scale, but to show it on the screen, I'm drawing like this. Okay. So then inlet feed stream somewhere in the middle. This feed, as we said, consists of mixture of A and B, that is binary system. This enters the distillation column somewhere in the middle of the tower. This tower contains trays. Yeah. I'm just showing you the trace in a what you call straight lines here. Yeah. So once this particular position or once this particular column gets filled up to this place with the liquid, this liquid is taken from the bottom to the reboiler section here, wherein we supply heat, and then the vapor coming out from this reboiler is made to enter at the bottom section, at the before the bottom tray. It is made to enter before below the bottom tray, so that the vapor goes up like this. So how the vapor is generated? So actually the feed which I am considering is a liquid phase. We are initially filling the tower to some extent. That means this is known as hold up, and then after filling up to some extent, I actually try to fill this reboiler also, and then supply heat. How I supply heat? Through steam. Then some of the liquid gets vaporized. It is not all the liquid which is getting vaporized. So this is known as partial reboiler. Hope I am making some sense. Okay. This is known as partial reboiler. Okay. So this is going up, and then the vapor coming out from the top of the tower. This is known as the vapor which is coming out from the top of the tower. Yeah. So this is vapor. Okay. This is feed F. Yeah. Vapor which is coming out of the bottom of top of the tower is sent to a condenser. It is sent to a condenser. Now this condenser, let us assume to be as a total condenser. Yeah, this is considered as a local condenser. The line which you are seeing, the line which you are seeing here, this particular blue line, which is showing like this represents this total circle, and this represents a heat exchanger with a cooling water circulation. So that intends that is actually the meaning of that. Hope I am making some sense here. So this particular arrowed line, I am trying to tell you what is this arrow line. Okay. Then here this is vapor. Once this is condensed, this becomes liquid. Okay. This is stored in a reflux drum. Okay. From the reflux drum, part of this is sent back to the column as reflux, and part of this is sent as a top product called as distillate. Yeah, but still, let us actually forget about this particular distillate part now. Why? Because I am just considering a total system wherein feed is given to some extent hold up, then the feed is cut off, then heat is given, and the vapor which is going up is condensed and condensed to liquid phase, condensed in a total condenser, liquid phase, and it comes into a reflux drum. This is known as reflux drum. From the reflux drum, the liquid is actually transferred back, sent back to the column as L0, that is known as reflux. So L0 is known as reflux. L0 is reflux. Okay. So this is what happens actually. How long should I run this particular setup? This is now we are trying to bring the column into equilibrium. What are we trying to do? We are trying to bring the column to equilibrium. Equilibrium means, as we said, A is more volatile. So that means more volatile means A will try to be enriched in the top section. So component A will be getting enriched in the top section. So we take a sample out of here, and we take a sample here, and we check the composition, and we check what? Composition. This composition, if it is achieved as we desired in this area, then slowly we start drawing the product, which is known as D, that is distillate. Okay, that is distillate. That is what this particular D comes into picture. Okay, so this is D. This is known as distillate. But once you are drawing the distillate, that means from the system some liquid is being sent out. So you start giving feed again, start giving feed. So F is equal to D, you are giving D here. So F is equal to D, D is given here. Once you start giving feed and then some distillate is being drawn, now you start drawing bottom product also, which can be represented as W. So in this whole scenario, what are we trying to know now is that there is feed F, after equilibrium is attained, products are drawn as D as a top product, W as the bottom product. Total, that means we can write an equation called F is equal to D plus W is the total material balance. But we are interested actually in a component A. Further, I don't want to discuss on how do we do metal balance, component balance and all those things. But my intention is to actually tell you how a distillation column works here. Okay. Now, very other small important aspect. See, we are supplying heat in the reboiler. So heat is supplied here and heat is removed in the condenser. Heat is removed, heat is supplied. So these two are known as, this is known as QB and this is known as QC. So QB and QC are known as heat loads at reboiler and condenser. So in the reboiler we are supplying heat to generate a vapor phase, from the liquid. In the condenser we are removing heat, that means latent heat, to change the phase from vapor state to liquid state. Some part is refluxed back, some is actually collected as residue, some is top distillate, some is collected as the residue or the bottom product. Okay, so this is the intention of this total video. Hope you got the essence, or you could try to actually make a clear sense of how a distillation tower or a fractional distillation helps in separating a binary system. Okay. See you in the next video on further topic on distillation tower.